For our first example, we have the sums and differences of functions on a graph. So we don't have the equations of each function, but we are still able to gain the sum function and the difference function. So for our first example, we have h of x is equal to f of x plus g of x. So we are trying to find the black line, which is the corresponding sum function. First step is to find our common x values. So we have -3, 1, -1, and 3. They're all pre-labeled. First step would be to add the corresponding y values of each coordinate that the x coordinates share. For example, on the g of x graph, our first point label would be -3, 0. And on the f of x graph, the red graph, we have our first point being -3, 1.5. So in order to get the sum function, we would add those two y coordinates together. 0 plus 1.5 would get us 1.5. So at -3, we have that value of 1.5 for our h of x function. For the next one, we have 3, and we have, right here, we have 3, and we have 5, or 5.5. So the corresponding y value of our sum function would be 8.5, because that's 3 plus 5.5. So it unfortunately went right off the graph, so I drew it right up here, and it should be around, let's draw that, 8.5. So we still have that -1 value for our x value, but we have a new y coordinate of 8.5. For the next one, we have 4, and again, 5.5. So 4 plus 5.5 should get us 9.5, and still in the 1 area, that would be right about there. So we are going to plot that point. There we go. Then we have our next value being 3 on our x-axis. So we go to the points that have corresponding 3 x values, and we have 1.5 again, and we have 3. So 1.5 plus 3 gets us 4.5, so we can go ahead and plot our point on 3, 4.5 right there. Then we can connect all of our dots, and we should have a nice parabola. That would be our, extend the lines here. Let's go back, approach, up. We can extend our lines and draw our arrows. That would be our approximate h of x function in black. Then same thing for the I of x function, which is our difference function. Instead of adding the corresponding y values, we just subtract them. So for that original point being 0 and 3.5, or 1.5, 1.5 subtract 0 still gets us that value of 1.5. Make sure you guys are careful. We are trying to find f of x minus g of x, which remember is that red line minus that green line, okay? So we need to take that x or y value of the coordinate of that f of x function and then subtract the g of x function. So that would be 1.5 minus 0 to still get us that value of 1.5. Next point is at -1, so we take our f of x function, which is 5.5, and we are going to minus 3. 5.5 minus 3 gets us 2.5, so we can go ahead and plot our new point at -1 and 2.5, which is going to be right there. For our next coordinate, we have 1 on our x-axis. We'll follow that one right up. We have 4 and 6. Remember, we're taking our red and subtracting our blue. So 5.5 minus 4 gets us 1.5. So we can go ahead and plot that on our graph. 1.5, good. And then we can go ahead with our next point, which is at 3 on our x-axis, right here. Remember, red subtract blue, that's going to get us 1.5 subtract 3. 1.5 subtract 3 gets us -1.5. So we can go ahead and plot that -1.5 on our 3x value. So then we can join our lines together, look at a nice parabola, extend our lines, and that way we have our I of x function. So pretty much that is graphing our sum and difference functions. See, that wasn't too hard. You can apply this example to any time we have a